millions of hectares. So there's over 400 million hectares in commitments committed by the under the land degradation neutrality. But also for the Climate Change Convention, the NDCs, the National Determined Contributions, there's also a substantial area, over 200 million hectares. The NBCEPS is substantial but a bit lower. This is for the Biodiversity Convention, that's slightly below 100 mega hectares. And also the Bond Challenge, that's a specific challenge about forests. That's also about 200 mega hectares, so that's a large number, of course. However, there's actually, it was also mentioned in the previous session, the one before actually, there's quite some uncertainty in how these estimates overlap. Yeah, I think this was discussed a bit in the session on Rwanda. So this is of course the global perspective, so it's much wider perspective. And here we have a difference in the low, middle and high estimate, and this depends on the assumptions that we make on overlap. So in the low estimate, we assume full overlap between all different types of commitments, whereas in the high estimate, we assume they are all add up together. And in the middle estimate, we actually have a bit of a more advanced assumption where we say that each type of commitment, if they are similar, so commitments on forest or commitments on croplands, they don't overlap, but if there's two commitments under different conventions or agreements that are both about cropland, then they do overlap. So that's the middle estimate here. So we think this is the most realistic estimate, and it's slightly below 1 billion hectares. So that's really a large total number of commitments that there is out there. And this is when we look at these same numbers on the regional scale. So we have these 10 geographic regions that we look at in this PBL's land report. And these squares represent the different areas. So the middle square, the darker one, that's the commitments that I just showed in a different form. Then the largest square, that's the total area of a region. So if you compare the middle one and the outer one, that's how the area compares to the total area in a region. And then the dashed one, that's the restoration potential. I'll come back to how this is exactly estimated, but this is the PBL's estimate of land area in a region that can be restored. The most important takeaway message of here is actually that the largest share of commitments, as we already heard before as well, is in Sub-Saharan Africa. So Sub-Saharan Africa has a large number of country commitments, which add up to a large area. And also compared to the total area of Sub-Saharan Africa and to the degradation of the restoration potential, as we estimated this is really substantial, so that's very big. Also in Central and South America and in East Asia and South Asia, these commitments are very large. On the other hand, especially in Northern America and Western and Central Europe, Russia and Central Europe, they're quite disappointing, so to say. So there's a much lower share. And yeah, I really feel there's the discrepancy in the commitments, so to say, between the different global regions in this on this topic. So that's an important takeaway message here, I would say. This slide goes into the thing that I already alluded to before, are the different types of commitments. So I hope you can see it reasonably well. On top here, we show, so this is the area again. So on the bottom here, it's the total area. So it adds up to slightly below 1 billion again, 1,000 million hectares. And here you can see the different types. So the top here, that's the largest commitment area, that's really about forest. So a large part of this is about forest protection, which is part of the NDCs, for example, but also forest restoration, improved management, those kind of things. And this is a really large share, so that adds up to almost 400 million hectares, which is about 10% of all forests globally. Then croplands, commitments about croplands are also very substantial. Those are about 300 mega hectares, I think, million hectares. And that's actually 20% of total cropland area. So in a share perspective, that's actually more than the forest commitment. So there's a lot on croplands and forest. On grassland, it's much smaller. Grassland area is actually much larger than cropland area, about twice the size. But the commitment there is much smaller. So that's something that's also important to notice, that about croplands and forests, there's quite some ambition. But grasslands are really missed a bit, so to say, even though there's a lot to do there, of course, with overgrazing and different management types. There's also some rest categories here, multiple. Big thing of there is wetlands. So that's, of course, a small area, but not to be underestimated in importance. And also here, protected area. If I'm not mistaken, that's not specified as clearly. If it's about forest or grassland, then it would be specified in those categories. But it's also a reasonable part of the commitments here. All right, I think that's all I have on the country commitments. We'll have enough time afterwards for Q&A. But first, Ezra will dive into the global cost of land restoration.
Yeah, thanks, Jonathan. Yeah, I'm going to talk to you about research we did on the cost of land restoration, and that's a bit similar to actually the previous session we had from WOCAT and from the University of Bonn, although a bit different. So let me talk to you where these differences arise. I want to emphasize this work that we did together with the team from PBO and Wageningen University. The study actually found its way to the Global Land Outlook. You may have read it in the last report, but it's also a paper submitted to Nature Sustainability. So the rationale for the study is, and like Jonathan said, there's this large amounts of restorations, large restoration commitments being made by various countries, and obviously this requires a large scale of investment. And we wanted to know, okay, how much exactly? But answering that question, we quickly realized, okay, there's large uncertainty about the lack of knowledge on the cost of investment, basically. And first, kind of the literature revealed a paper where it was mentioned, and I'm not lying, a difference between, or a range of the lowest of $2 per hectare to the largest of $10,000 per hectare. So that's an enormous range of potential costs of restoration options, and we thought, well, let us try to do that a bit better and try to see if we can come out with more precise estimates, basically. So what we did is we constructed a cost database. Was also mentioned actually earlier on the panel by our colleague from the Global Mechanism. We had a cost database of 232 entries, basically compiled of upfront investments plus 4 years of maintenance, and we sourced those data points from different databases, basically. From the WOCAT database, we had many entries. We searched the World Bank project database to get World Bank data on restoration projects, and that was complemented with some journal articles and some information from key experts. Then we set up an econometric model, a statistic model, to understand the variation and to get precise estimates of, basically how these variation cost estimates can be explained across different types of restoration types, across countries, accounting for different capital costs, accounting for differences in wages, and also for differences in the data source. Because quite early on we realized that the difference or the estimates, for instance, in the WOCAT database are very different from the estimates in the World Bank database. And we used that to estimate this model, and subsequently we tried to put a cost figure on the total of these restoration commitments that we had in the database that Jonathan presented earlier. So these are some insights, the descriptive statistics, if you will. You see actually is this the pointer? Yeah, you see the large ranges for many of the different restoration options, so from agroforestry all the way up to water management. So large variations, less precise estimates of the cost actually, and of course that makes sense because you have cost across many different settings. But still there are some takeaways actually from these descriptives. Some are definitely higher than others, so we have high median costs for things like irrigation, silvopastoral management, cross-slope areas and agroforestry, so things that require changes or actual changes in the landscape, and things that are notably cheaper with cost of less than $500 per hectare, things like forest management, grazing management and passive regeneration. So some clear difference across the practices. And the model revealed some other differences. So this is what I just mentioned, the first bullet point, the differences between a hard restoration measures, things that you change in the landscape, and things that are more management related. We find also that costs are significantly lower in low-income countries, and that's probably a wage effect, and that was also mentioned actually in the previous session before us. So restoration options are cheaper in developing countries because of lower costs. And we found that the WOCAT estimates are significantly higher than the World Bank estimates. And that's probably because the WOCAT estimates are precise, smaller type of interventions, smaller type of project descriptions. So they are more precise estimates, whereas World Bank projects that we reviewed are typically large projects of several thousands of hectares in let's say, Kaduna State, for instance. So they're probably less precise on the precise cost in the field. That being said, there could of course be economies of scale that could make a plea for the World Bank database or the World Bank data. We're not making a choice between either of one is better than the other. We're just saying there's differences in cost across the different databases, and that's something to be aware of. So based on this model, we put that basically over the restoration commitments database that we had developed and that Jonathan presented earlier. And we put costs to all those commitments, and that's what you see here. It's a bit small. I hope you can see. I hope you can see it. And we used the two cost estimates. The blue as the World Bank data cost or the World Bank cost, and in yellow you find the WOCAT costs. And you see indeed that the yellow bars are much higher, indicating indeed that WOCAT costs are higher. That's one observation in this figure. The other is that there's significant differences across the continents, and that's also a result of what Jonathan was mentioning earlier. So we have very high costs for sub-Saharan Africa, simply because there's lots of commitments, lots of pledges being made by African countries. And even though that the costs are lower, that's still a very high figure that you got here. And that's same, you find similarly a high cost for Central and South America, and for some of the Asian countries. And you find very low costs for countries like Europe, for European countries and for North America, because less pledges are being made, even despite the fact that costs are higher in these continents. So what kind of figures are we talking about then? Well, we have slightly less than 1 trillion hectares of restoration commitments, as was presented also in earlier sessions today. Putting our cost figure on that would yield an estimate of ranging from 252 billion to 1.6 trillion US dollars. That's an enormous amount. Even though the per hectare costs are still manageable, we're talking about $400 to $2,000 per hectare, so that's much better than the earlier range we had from 2,000 to 10,000. So this is a bit more precise, but still, this is a large amount of money, right? It's about 0.3 to 2% of global GDP. I think it's a lot of money, but you can also say, well, it's relatively small. I mean, given total GDP anyway. But there are strong distributional issues. Like I said, Sub-Saharan Africa, Asia, and Latin America have the bulk of the commitments. And for those countries, it is a significant share of GDP. So for Africa, for instance, we're talking about 37% of GDP of costs of restoration commitments of their GDP. So that's a lot of money. And of course the question is, who's going to pay that for that? That's another question we are answering, but at least that's being taken along in the discussions, I think. So we provide the data and the better insights for that. So some key messages, take-home messages from this case study. In relatively, these costs are modest, or it's still up to 2% of global GDP, but in absolute terms they're pretty large, of course. There's unequal distribution of commitments and thus costs across different countries. But restoration options are relatively cheaper in low-income countries. Some words on the approach. As a good scientist, I should say, well, there's things to be improved. I think what we want is clearer harmonization of data on costs, basically. That was really difficult in this study, compiling cost data from the different sources, from the World Bank database and from the WOCAT database. There's very different standards of reporting. That makes it difficult to compare. But anyway, we counted for that in the statistical approach, but it would be good to have clearer data, basically. We didn't have data on opportunity costs. That's the last thing I want to say here on this, actually. It's good to know what something costs, what agroforestry costs per hectare, but it's also good to know what farmers are giving up. So what were their incomes in the practice that they were practicing before, to make an understanding of how large the benefits are from switching from their previous land use management solution to a new one, basically. And that brings me to the next part of this presentation about benefits. And of course, one benefit of having better cost estimates is that you have better information to compare it against with costs, or with benefits, basically. So better cost estimates allow for better understanding of how large are the cost-benefit ratios, for instance. So that's what I'm going to talk about next. So a study that we also did in this project on GLO within PBL was on the socio-economic impact of land restoration. Again, a joint study with colleagues from Wageningen and PBL and a colleague from IFPRI. This has also been submitted to a journal. And when we started this work, basically we wanted to know a very simple question, and we asked ourselves, okay, let us pick a certain restoration measure. Let's say agroforestry. What is the expected increase in annual income for a household starting to adopt or starting to practice agroforestry. And next we said, okay, if we have that information, we want to have a bit more information into the variations. So, okay, what's the differences across different settings, across different countries? But could we also say something about how this annual change in income is affected by how the projects are being set up? So how technologies, well, it's a bit of an old-fashioned word, technology dissemination, you would say 20 years ago, but how people are co-learning about a new project, how people are, how the project is basically implemented. Can we say something about that? So basically the underlying question is, okay, what works where and how and why in order to enhance the effectiveness of our work, basically. So, and give the spoiler of my talk, we couldn't answer these questions, actually. So let me tell you why. To approach this question, we conducted a systematic review of the literature. We focus on aggregate household level. We wanted to focus on aggregate household level income, basically. And that's important to know because lots of projects or lots of publications or lots of studies focus on plot level impact, but we really want to know a little bit higher what's happening at the household, what's happening to net income of the household, what's happening to food security at the household. Can we say something to that as a function of starting to adopt these new practices? And we want to focus on real life conditions. So we want to move away from studies that focus on trial plots, on NGOs having showcase plots, but really after a couple of years in real life interventions with farmers practicing it, what happens then? To keep it manageable for ourselves, we focused on the agricultural domain, so on 4 specific restoration methods there: soil and water conservation, integrated soil fertility management, conservation agriculture, and agroforestry. And we wanted to focus on rigorous impact evaluations. And that's a thing as economists, we like that. But we really want to have a study that shows after several years, okay, you find an impact, you find a change in income, and you can really attribute that to the project intervention and not to other things, not to that effect that prices changed over time or that there was another project 10 miles away. No, really that you can make the link between the intervention itself at time t=0 and the impact after several years later. Well, we spent a lot of time finding those papers in different databases. We've written automated searches. We started basically from over 4,000 potential publications, and we ended up with a much smaller set, 46 from the database that we had initially constructed, and there were another 18 studies added from key experts and from snowballing from those initial publications. We read those in detail in a group of scientists. We scored them, and we had to score them because applying a good impact evaluation method is one thing, but applying it correctly is another thing. So we had to make sure that people were really doing it in the best possible way. And we gave a score of a low, medium, or high risk of bias, and low and medium risk of bias are the studies that we ended up with that we thought, okay, these make really the case, the best case of showing a causal impact of the land use or the land restoration option. So some takeaways here, and I should say, let me go back to the previous slide. So we ended up with 12 plus 17, so 29 studies in total. And we're talking about things like agroforestry, conservation, agriculture. They have been around for a long time. And we were really surprised to find only so few actually of them. That's one key observation here. What is more, only few of them were of the most rigorous standards. So the World Bank would use would deem it gold standard, or would call it gold standard. So there's a randomized control trials or difference in difference methods for the statisticians in the room, but I won't bother you with the details. So those are in here on the left side, but most were of less accurate approaches, less accurate statistical approaches. And that's also seen here by the reddish, that sort of high risk of bias study. So lots of them we had to still throw out, basically. What is very interesting is when we started looking at the geographical spread of those countries, is that they were clustered in a very small set of countries. So we had 29 studies, 8 of them appear in Ethiopia, and virtually all the others appear in Anglophone Africa. There's a couple of other studies, or 2 basically, one in India and one in Syria. But there's none of the studies is from Francophone Africa. And that was an interesting finding, and we were wondering whether that's either due to our search, because we've been searching English abstracts, but then again, many French journals also have English abstracts, so we did include some French publications, in fact. or that there's a distinct difference between how French or how the Francophone and the Anglophone world conduct science. That could be one explanation. Then we constructed what we call an evidence gap map. We just put dots in this figure where we show where these publications end up. So you have on the rows here the different interventions that we were looking at. So soil and water conservation, integrated soil fertility management, conservation agriculture, and agroforestry. And then here the type of impact indicators that the publications assessed, basically. Well, one notable thing is that we don't have anything on agroforestry. That is, I can't explain that. It's very, very surprising actually, because, and also agroforestry is something that's been around for decades already. And then most of the publications assessed impact still on the farm level, and that was not our first focus. We included it in the end, otherwise we would have not have had much basically in this study. But we were really interested in these type of impact indicators on household level, on income changes, on food security, on poverty. What is really happening to the household after several years? And there's only a handful of studies that provide a bit more insight on that. So that's another observation. In terms of the impact that studies find, many of the studies, or the majority of studies, find a positive impact. So that's good. I mean, that's what we expect. That's what we tell each other in these rooms, that these land restoration options have a positive effect on the household. So indeed, many of the studies observe that. But also interesting is that not all of them find a significant effect. There's still about 30% of the studies that actually found a no effect or no significant effect on these household indicators or farm level indicators. So that means that in several instances, these restoration options do not make a change after some time. Basically, that's the conclusion. So in terms, I'm not sure if we're time-wise still doing fine, but okay. So some of the key messages really from this systematic review. I think the point I really want to drive home here is we really need more and better impact evaluations. There's really a handful only of them. And in order to understand what works where and why and how to make projects more effective in land restoration, we really need to have a much better or bigger data set or bigger amount of studies that showcase impact. Nonetheless, and I mean, we're still able to say a few things on the scarce data that we had. What has come out is that, especially for integrated soil fertility management, many of these studies find a positive effect, and that's good. But we're also wondering whether that's actually a function of the fact that many of those interventions also stimulate the use of inorganic fertilizer. And that could, of course, be a reasonable outcome. I mean, fertilizer makes land more productive. But we also wanted to know a bit more on the other things, on manure, on compost, on crop rotation. And there, again, we have little insights, in fact. We find that soil and water conservation is especially beneficial, and that comes out of the studies, all the studies we had on this, in areas with temperature shocks and low rainfall. So really in precarious situations, basically, where it makes sense indeed, where the high cost of investing in those soil and water conservation structures, they also pay back. So the more dry areas, the Sahelian areas. And some studies hinted at possible synergies between practices, for instance, or most notably on minimum tillage as a component of conservation agriculture, and some of the ISFM practices, and then most notably, inorganic fertilizer use again. That's what I had to say about these two studies for now. So.
Thanks so much, Ezra. So then I would like to invite Baron Orr, lead scientist from the UNCCD, if I'm saying that correctly, to reflect a bit on what you've so far heard. That's it. And then we have time for Q&A.
So good afternoon, and thanks for letting me do a little science instead of negotiating. So for me, this is really important because at the end of the day, if we can't demonstrate a return on investment, then how are we going to get the investment, right, on the ground? And so I guess I'll start out with just kind of a summary. The good news here is that there are 1 billion hectares almost that have been committed globally, and that it is something that's across all three conventions and the Bonn Challenge. I think that's really important to keep in mind, and that it's possible to cost that out. But the downside that we picked up in this discussion is that we don't have really a harmonized approach among all those economists that are taking this on. And I think that's something that the community needs to really seriously consider. We had this discussion once when we had a bunch of the groups that are interested in understanding the return on investment and restoration just before the pandemic, visiting the UNCCD, but I don't know how to nudge that a little bit further. I think it would be very important to agree on those things that can be harmonized so that we're in a better position there, because it holds us back. It's the most frequent question asked, and if we can't provide that in the Secretariat, we're really handicapped in our efforts to push towards more investment. So the large ranges are not only due to the differences, though, of course, right? I mean, there are different circumstances on the ground. I mean, there's a lot going on there, and I think it was heartening to know that the research led to narrowing that range. So we're going in the right direction there. The other thing that I found interesting is that when we apply the costs to different regions, so first of all, if we add it up globally, we're talking about a significant amount of money. I think the GLO puts that in context relative to how much we subsidize fossil fuels, et cetera, and then all of a sudden it's a very reasonable number. So I'm not so worried about the big number, but the fact that 37% of GDP in sub-Saharan Africa, that very much worries me, because this is where we really need this kind of investment. How do we deal with that kind of variation is something it's really important. I was very intrigued by the efforts to pursue socioeconomic impact of land restoration, and to look at that at the farm and the household level. I think that's ultimately where we want to go. If we're going to make the argument that restoration does lead to an impact on income, we've got to have more research in that area. I have some insights on why you're probably not getting much on agroforestry. It takes a long time to grow trees, and I think that's a part of it. But it also says a lot. I mean, I don't know if anybody is here from the World Agroforestry Center, but I think we have to turn this around. I mean, we can't have lack of these kinds of studies and keep this agenda moving forward. I found the other thing that I observed here is that, as you probably have seen in some of the GM oriented side events where they're talking about value chains, there may be other dimensions that we want to figure in, right? So that it may not only be the practice itself, but how well linked this becomes to value chains, sustainable value chains that lead to it becoming economically viable to the household. So that's something to consider. I don't know if it was built into the analysis, but something to consider. And then when you mentioned the uneven spread, the slide wasn't up very long, but if I'm not mistaken, I didn't see Latin America at all. I'm not sure. So it is quite striking where we're talking about linguistics differences influencing this. So is it because those studies are in Spanish only, et cetera, journals? I don't know. But it is a great concern, and it strikes me that it might be worthwhile. I mean, there weren't that many studies that qualified. It might be worthwhile to contact all of those authors and have this conversation. You know, what's going on? Why is this so narrow, and what do we need to do to broaden it? And then I guess the last thing I would like to observe here is there's some harmonization, or maybe that's not the right word, but the methods that you employed to both identify what qualifies and the methods that were used in the articles that you said were quite varied, maybe we need to develop some guidance, right? I mean, there are many scientific areas of research that reach a certain place where some very specific methods are agreed and then applied, then on. And it's very rarely done in economics, but it is done, right? I mean, look at GDP itself is an agreed standard. So maybe that discussion needs to take place in the community that's interested in this area. So those are my observations. I feel like I'm throwing them out from the peanut gallery, but nonetheless, I throw them out for your consideration. Thank you.
Well, thank you, Baron, for this good reflection. Now we'll open the floor for questions, and we have about 10 minutes. And yeah, how are we? Tu vas faire circuler? Voilà. Okay.
Thank you very much for your presentation, and yeah, just very interesting insights into restoration opportunities. I think my questioning is, I've got two questions, and it's also kind of, it depends also on how you define restoration itself. Sorry, I'm Kyra Landerstedt from UNDP South Africa. So my first question is related to the first presentation, and that was if your restoration and the costs of restoration were at all linked to the severity of land degradation within those countries. So especially if you look at the LDN response hierarchy of avoiding, reducing, reversing land degradation, it would be important to look at the severity of land degradation within those countries relating to the costs of restoration. And then my second question is just around looking at biodiversity benefits that can come from restoration, especially because as Africa we are really blessed with a wildlife economy, and there's various benefits of also avoiding, reversing and reducing land degradation, which would, there's certain economies that come from wildlife. So I just wonder if at all you looked at the wildlife or nature-based biodiversity benefits linked to socio-economic impacts. Thanks.
Yeah, thanks. The second point, indeed, we did not, but we had a very narrow focus on agriculture because that was, we had to keep it tractable or manageable, basically. We already ended up with 3,000 publications initially to start with. So those are things that that you may consider, but then we would also consider different types of restoration options or different type of land uses, I think more forestry-based approaches. But that would definitely be an interesting angle to look at. The other point, the first point is about the severity of degradation. That's a good point, and we've been pondering about that. And at some point, we thought, yeah, we should actually overlap the costs of those projects with information that we have about the type or the status of degradation in those areas, because that would need to give a nice explanation. But that was a thought. In the end, it was too cumbersome, too complicated, basically, to pursue that line of approach. But that's something, perhaps for the future, need to look at. That's yeah.
Other questions? Oui, madame là-bas.
Just a question. So you're going to have before scenes and after scenes so that we can see. Are there going to be comparisons? You have all these commitments. Are you going to have before pictures or whatever and after pictures? I'm thinking about the quality of the commitments. People can make commitments and nothing come true. Did you have local consultations with the people to get that people component into it, or it's all modeling?
Thanks for your question. I think I can say a bit about the first part, but maybe Ezra can step in for the second part. These commitments are country commitments. So this is really what the countries have pledged in all these different fora. So we have not been looking at how well we're doing in that respect. So we've not assessed that basically. And that, I think that is a big issue here, that we have all these commitments, but there's not really a way to check that, right? We don't have a mechanism that says, okay, you've committed to this. It's not a legal structure. They're not legally binding. So I guess that is a big issue of these commitments, that we don't have that. Yeah, that's would be nice. I think Bergen wants to say something here.
But it's the right question. I mean, the fact that that's not easy is a big bottleneck. And the Science Policy Interface, after reviewing the special report on climate change and land of the IPCC, noted what PBL produced, and put in a recommendation that this continue. Because sometimes when you make the insight available, and imagine until they did this, it took them 2 years, I think, maybe more, to go through all of these individual, clearly not harmonized reports from governments and add up to 1 billion hectares. It was a large and significant process. So the SPI said, well, let's do it again, and let's make it regular. And that decision passed. So it actually was adopted by this CST. It's not done yet because it's got to go to the, actually it is. It also got passed by the COP. So we have that big step. And obviously the intent is to see action on those commitments, to turn them, I mean, the language even says make them spatial, et cetera, to move in the right direction. So I think you're asking absolutely the right question, and we have to keep nudging these governments to, it's not a transparency issue only, it's organization, right? Everybody does everything differently, and how do you get them to do it in some common way? We're pushing them in that direction. Don't say that out loud, but we are. Thanks.
Ezra, do you want to add something, or you're okay? Any other questions? Okay, there, Madame.
Thank you for the opportunity. My question relates to one of the slides I saw where you have put that the interventions are many, but the outcome is like a dot. So, okay, without prejudice, where are we doing this as a side event when it can be done at the plenary where the, the parties are there and are able to see the data that you have worked so hard to produce? I'm not getting why this is a side event when it is such a powerful tool that you have developed and you continue to develop, and you have so much interest in it. Thank you.
I'd be a bit nervous to stand at the plenary session, but I'd like to. But I'm not sure if Baron has a comment here, but yeah.
So part of it is procedural, right? I mean, it takes a lot to put countries in the position to be able to agree on something. When they agree it, we spend the next 2 years trying to accomplish what they've requested be accomplished, and then we go to the next step. This research, some of it's not even published yet, right? So it's not in that cycle yet. However, this group contributed to the Global Land Outlook, the 2nd edition. That's a little bit, it's got a scientific review that's mandated by the COP, but the actual science-based communication is a innovation of the executive secretary, both the current one and the previous one, which was the 1st edition. Some of this, not all of it, because some of it came after, but some of this informs that. And if you read the key messages in the GLO, they are hard-hitting key messages. So at least it's in the public realm. And I don't know if you've seen the media response, but it's been very large, much larger than anything I've ever seen coming out of this convention before. So it's not fully where you want it to be, but at least it's moving in the right direction. Let's put it that way. Thanks.
Thanks, Baron. We will now move to the next segment on the land restoration scenarios and the scenario study for Eastern Africa.
Yes, thank you, Eli, and thanks for the lively discussion. Yes, so we now go to the second part of this presentation about the degradation and restoration scenarios that we've developed at PBL. And I first wanted to put this slide up here, which kind of tries to conceptualize the concepts of degradation and restoration and how we use them in our modeling approaches. It's a bit small, sorry about that, but at the top you can see how we go with different increasing land use intensities from a natural condition to an extensive land use condition, intensive land use condition, and in the end, if it's overly intensely used, to abandoned, degraded land. And here we conceptualize this with different services, ecosystem services that come from these uses. So if you have a natural condition, you have relatively small crop and grass production. However, you also have substantial contributions from other services, such as carbon storage, soil fertility, water regulation, and biodiversity. So those are the 5 types of services that we look at typically in our approach. And this also, of course, relates back again to the 3 conventions and all the interlinkages between these the 3 topics, between climate, biodiversity, and land. Yeah, so important to emphasize here is that we look at degradation, as I think most of us do, in a broad perspective, right? We don't just look at the cropland and how that is less productive, but we look at it in a broader way. So we look at all these, we look typically at these 5 types of indicators. So carbon storage, soil fertility, which is in terms of soil carbon, water regulation, biodiversity, and the crop and grass production. And then on the bottom here we have the restoration and ecological restoration. So that's also an important distinction that we make, and that will come back to later. So we have the rehabilitation and sustainable land management, so that coming back from a really abandoned, degraded land to land which can produce again and which is useful for agriculture. But you can also go all the way back to ecological restoration. However, as you can already see here, and there is of course a bit of a trade-off there between food production and ecology, biodiversity. So I think it's a very important topic as well. However, basically land restoration has the potential to deliver multiple benefits simultaneously, and that's what we're looking at in our scenario approach. So this is the key concept that we've developed. So we have 3 scenarios to quantify degradation and restoration at a global scale. And this is a stylized graph to look at this. And typically we have a historic period, which is constant for each, is the same for each scenario, of course. And then, then we go really into the scenario period. So we have a baseline scenario, which continues business as usual. So what's happening under continued population and economic growth, current practices, so to say, and some basic developments in technology, those kind of things. And then you have a certain development, which I'll show about more in the next slides. Then we have a restoration scenario where we implement large-scale restoration measures on all agricultural areas in the world. And then we have a third scenario, which is called the restoration and protection scenario, where we also implement this large-scale restoration, but in addition, protect ecosystems. So those are the 3 scenarios that we have. So that's the basic concept. How do we do this? This is the modeling part. So we use integrated assessment modeling, that's what we call it. And basically, this is programmed representation from land use, vegetation and water modeling, agroeconomics, but also satellite data trends and much more. I don't have the time in this session to go in lots of detail there, but happy if you're more interested to have a look at our report or underlying things, and also just come up to us after the session to have more discussions on this. But yeah, there's a big framework of different modeling and methodological approaches underlying these scenario developments. So these are some of the results, some key results of the baseline scenario. This is based on the SSP2 scenario. For some of you may know that. This is actually originally from the climate change community, but it's a business as usual scenario, shared socioeconomic pathway, where population continues to grow in some regions, other regions stabilizes or reduces a bit. Also GDP continues to grow. And then what you see here, this is an index for a few key dimensions for the land use. So this is animal production, crop production, of crop demand I should say, agricultural yields, and cropland area. And you see that they all continue to increase. This is the historic period, and this is the future scenario period. So they continue to increase. And then this is a map of the resulting land use change under the baseline scenario. So all these red locations are where conversion of natural land takes place because of these baseline developments up to the year 2050. So we're looking about 30 years ahead. So that's important. And most of the conversion takes place in Sub-Saharan Africa, Latin America, but also quite a bit still in Southeast Asia and Central Asia. And in total, this is about 300 million hectares of additional conversion from now on in a business as usual case. And this is about the size of India. So that's really substantial. That's a lot. And this has consequences, of course. However, first I want to highlight this. So this is how in our modeling we explicitly include the degradation. So this has really been quite an innovative thing that usually these vegetation and crop models are only driven by water availability and climate dynamics. The soil plays a very small role in this, but we explicitly include historically observed, over the last 20 years, observed degradation trend based on satellite data. So this is greenness, normalized difference vegetation index for those who are interested. So we detect in what locations in the world we've seen this degradation going on from 2000 to 2018. And this is detected then on 1.6 billion hectares. So that's also a very large area. So this is about the size of South America, and I think this is slightly below the 20% of current global area, which has seen a degrading trend over the last 20 years. There's a few different numbers of this degrading area out there, so that's I think there's also there a bit of a definition issue, but this is the specific approach that we used, and then we use this data to include this degradation trend in addition to the business as usual yield developments. Bit technical maybe, but I'll also go back to the more basic results, but this is then how it works out. These are serial yields, and what you see here is how yields develop into the future. They typically increase because there's more demand. Economics demand that there's more intensification basically, so in general you see this increasing yields. That's this net change, the green bar. However, you see on the left side, you see these negative impacts. So we look both at climate change and human-induced degradation. So that's the thing that I described in the previous slide. And you see that, for example, here in Middle East, Northern Africa, are quite very hard hit by climate change and degradation trends. But also Sub-Saharan Africa here, for example, there's quite a. It's not massive, but it's substantial. So it limits the potential of yield increase in the future. So that's really something that might be. That there's potential to improve. So some more results from this baseline scenario. These are some two key points of these different indicators that I was mentioning, soil carbon and biodiversity. So here on the left you see a bar chart of biodiversity loss compared to a hypothetical pristine state in 2015 and 2050. And there's a big change here, so there's an additional 6% biodiversity loss in this baseline scenario. A big part of it is caused by land use change, it's a main driver, but also climate change has quite a big impact here. And so there's the 6% additional biodiversity loss, and also soil carbon loss. In business as usual scenario, these are the locations where we see soil carbon loss. That's another 32 gigatons carbon, and that's equal to about 3 to 4 years of current emissions. So that's a substantial amount. So this is some results from this baseline scenario, and then we go to this restoration scenario, as I was already mentioning. So I wanted to bring up this stylized slide again of how this works. So now we go from the baseline to the restoration scenario. So what do we do there? So basically what we do is at large scale, at all locations where we observe degradation in this historic period, we assume the implementation of restoration measures. And we have by now, for the people that have been here this afternoon, quite well familiar number of restoration measures, similar to the WOCAT database, for example, with conservation agriculture, cross-slope barriers, agroforestry, and a few more. And we make a map to see where these measures could best be implemented. So this is a rule-based approach. We look at all the locations where we observe degradation, and then we see what kind of measures could fit there. So for example, if there's a degraded forest, we can apply assisted natural regeneration or forest plantation. If there's already agriculture, it has to be either agroforestry or conservation agriculture. And grassland, for grasslands, for example, we can do silvopasture or grassland improvement, And then, unfortunately, we don't have a method at the moment to distinguish exactly the yield effect for each of these measures. So that's really something that there's still scientific need to further improve that. However, we assume that the continued degradation trend is reversed. So we have this yield effect, this negative yield effect, we reverse that. And then we look at the benefits. So that's the basic concept. And this is the same figure where we also try to highlight these different indicators that I've been mentioning, and they're linked to the SDGs. So we have here SDG 2, food security, SDG 6, water availability, SDG 13, climate, and 15, terrestrial biodiversity. So those are, again, the types of indicators, the types of topics that we look at. And then this is a regional graph that first is explained here about these benefits. So each little bar shows the benefit of these restoration measures on these different indicators. And this is what it looks like. So for example, here on the top we have improved crop yield. The blue one is improved water regulation, some carbon storage, remaining natural land, so organic carbon and biodiversity. And I think it's a bit difficult to read this, but I think it gives an impression of the differentiation between the regions. So that's the key point here. There's a large difference, again, geographically between the regions. But I think important, especially on the left here with Central and South America and Sub-Saharan Africa, there's a lot of potential. This can definitely help, right? It won't change it magically to everything to be perfect, but it helps. It helps a lot, and on all dimensions. So that's an important message, I would say. So I hope, I have more time afterwards, but yeah. So then we go to the second part of this scenario work, and that's when we start to add protection. So this is large-scale protection to protect biodiversity and ecosystem services again, and we have all these different small maps that protect areas for different reasons. So we have biodiversity, high carbon forest for emission protection, water regulation. These are locations that are key for sources of water, steep slopes to prevent erosion, riparian zones, so that's along rivers to ensure also water availability and management, and peatlands for the importance of wetlands, carbon storage, nature, etc. And then this graph shows how this restricts the land availability in certain regions, so how much land there's still available for agricultural expansion. And then this is some results from that approach. And what's key to see here, in these graphs you see the difference compared to the baseline. In the light green is just the restoration, and then the dark green is restoration and protection. And key thing to note here is that for some of these indicators, restoration and protection are very similar. So for example, soil organic carbon and water regulation, even if you don't do protection, they're highly improved by these restoration measures. So that's a big result there, I think. However, for some other indicators, especially for biodiversity, for example, here biodiversity indicator and remaining natural land, but also for carbon storage, that really also depends on this protection. Because of course you can imagine if we have expansion of agricultural land, we lose the forest, we lose a lot of carbon storage, and also a lot of ecosystems that are important for biodiversity. So it really depends on the indicator that you're looking at, whether they or not they depend on biodiversity, and whether or not they have a lot of benefit from these more agricultural-oriented measures. But this protection, there is a risk to food security, because especially we're looking again, if you think back from these baseline scenario, where we had a large conversion in Latin America, Sub-Saharan Africa, Southeast Asia, of course, these are also the regions where we expect still a lot of increasing population and increased demand for agricultural products. So there's a friction there, and that needs to be addressed, and that's really important, I think. This is a bit of a complicated graph. I guess it's too small bit for everyone to see, but the key point is that food prices increase if there's large-scale protection in our modeling results. Of course, there's many different options that you could also alleviate that again. But I think the key point from our scenario work is that this is a very important thing to focus on, that this conflict between ecosystem protection and food security, I think that is there. You can alleviate it by, for example, further improvement in yields. I think there's a lot of potential, or many other things, but this is something to pay attention to. And the other thing is the carbon that I already mentioned. So in our restoration and protection scenario, we find a difference of 83 gigatons carbon. So that's the combination of soil carbon and vegetation carbon. So that's that's really a lot. That's 7 years of current emissions. So that's really large-scale restoration measures on agricultural land. Soil carbon increases. We protect the forest and stop deforestation, basically. And then we have a lot of emission reductions. But again, as I already mentioned, for vegetation carbon, especially for forest, it depends also on this protection. For soil carbon, less so. It really depends on the success of the restoration measures on the agricultural land, basically. However, I also want to highlight that 7 years of current emissions, that's a lot, but it's not, I think, in some cases, that's what I find a bit difficult, because I work both in the climate change field as well as in the land restoration and degradation field. And then, especially in the climate field, sometimes talk about nature-based solutions, and this is a big solution. We can solve climate change by nature-based solutions, by land restoration. And that's really something that we should not say. It helps, but it's not a solution. It's not, if you just do land restoration, that you can solve climate change. So in climate change, it really needs to remain a lot of focus on energy and industry emissions, tackle those problems, and then land restoration can help, but don't depend on it. That's a key thing I want to say. One of my last slides, this is basically a bit of a teaser for some future work, hopefully. As I try to explain, we have these degradation trends that we observe from satellite information. However, that's not, that is a general trend, so that encompasses all different types of degradation processes. And we cannot really say, okay, this process has this consequence in this location, and this process has that consequence in that location. So that's something that we would like to do better and work towards. And we did this analysis where we assessed 6 different degradation processes, specifically for agricultural land, that we could get a bit of a handle on. So this is erosion, crusting, so that's whether or not the water can infiltrate soils, salinization, nutrient depletion for nitrogen and phosphorus, and overgrazing. So these are 6 processes that we assessed, and then we made a risk map with a number of these different degradation processes that overlap. So we count for each location how many of these processes occur there, and you can see various hotspots popping up. For example, in Central Asia, we of course in the morning had a presentation about Kazakhstan, the Aral Sea. We know the troubles there. We have here the deserts of Australia and western United States, where especially overgrazing is an issue, but also these other types of processes. And also sub-Saharan Africa, you see Nigeria popping up here, where nutrient depletion with phosphorus especially is an issue, but also overgrazing and erosion and the like. So that's really hotspots of these different processes. And our ambition would be to be able to model these processes better in a process-based way, so we can also say more specifically, okay, in this location we can have these types of measure that specifically address this issue. So that's something for the future. So, some key messages from our scenario analysis. No silver bullet for climate change and biodiversity loss. It helps, but it's not a silver bullet. However, substantial potential for multiple benefits for food security, climate change, water and biodiversity, and this risk for trade-offs between ecosystem protection and food security. I wanted to mention it one more time. All right, thank you. And then Ezra will have one final number of slides, not too much anymore. So stay with us about scenario work focusing on Eastern Africa.
Yeah, thanks, Jonathan, for your presentation. And let me finish off with a couple of slides on a pilot project that we did to bridge this wonderful world of scenario making, basically with actual on-the-ground policy making, or on the ground with national policy making. This pilot project came out in a report published by UNDP 1 year ago, I think, in 2021. It's called Future Perspectives on Land for Eastern Africa, and it's a joint collaboration basically by PBL, Wageningen University, the Joint Research Center of the European Commission, and last but not least, UNDP, and Eli was much involved in that project. And actually with involvement from 2 countries, from Kenya and Ethiopia were involved. So I think this pilot project started at the UNCCD COP in China, in Ordos, 5 or 6 years ago, I'm not sure, when colleagues of ours were presenting scenario work in the room, and Eli approached them afterwards and said, "It is very nice, it's these global scenarios, but can these be downscaled to country level, and can these be used to inform policy making or policy debates in countries?" And I guess I wasn't there, but I guess the answer of my colleague was, well, let's try and see if that can work. So that was the rationale. Can global scenarios be downscaled to something that's relevant? And we formulated a pilot project together with the four organizations involved, and we added some other focus points, like building a bit of capacity on scenario making in national policy making, to inform policymakers on recent trends on the 10-15 years in the recent past, but also inform them about potential future changes up to 2050 in land use and the broader impact on food systems, so food security mostly, and identify some of the key challenges or key policy challenges that are emerging from these data sources, basically. We had a meeting in Nairobi at the African Initiative to Combat Desertification in the East Africa chapter that was 3 years ago, I think, Eli, where we presented basically our pilot study to the audience in the room, and we decided to focus on Kenya and Ethiopia based on practical issues and also on data availability, and see if that works out, then we can upscale it or extend it to other countries and settings. So we joined efforts from different organizations. Like I said, we, from our part, PBL and we updated our scenarios and we downscaled them to country level, basically. JRC came on board, the Joint Research Center of the European Commission, to provide recent trends. So that's key recent trends related to land use, for instance, from satellite data, Copernicus data, but also from their degradation atlas, and complemented with some data from, for instance, the Global Forest Watch. And then the national governments or the national representatives on board, they provided the focus or the insights on their national policy focus. So we had the data on trends and future outlooks, and they looked at what's really being committed in our countries, what are the policy plans, what are the action plans being formulated, and put that on the table. And then the end question was, how does it all add up, basically? So how are the trends aligned to the scenarios, and how do the policy ambitions fit in? Are things aligned, or are there any discrepancies between those? That's what we set out to do. We had designed a pilot project to have 2 in-person workshops in Nairobi, one in Nairobi and one in Addis. But then COVID came along, and we had to shift the entire thing online, which we did in 4 online workshops together with national representatives, for us, of course, and national representatives from research organizations in both countries, with the UNCCD focal points, with some representatives from national ministries. And we presented our scenarios, we presented our key recent trends, and we discussed in the workshops. And in the end, we wrote a report about that. So we had lots of different data sources, and I'm not gonna tell all of them. This is data that JRC brought on board, for instance, on land use changes, on deforestation in the East Africa region, in green forest areas, which are still currently forest areas. In reddish or purple, you see the degradation areas. And they had more data sources, which I'm not going to share at this stage. And we had our models updated and downscaled to country level to really to understand the changes within countries. And we had produced maps of the best possible changes in land use up till 2050. and those are shown here. I want to highlight this one. This is land use change in Africa, in East Africa, so in Kenya and Ethiopia, of course. You see in yellow areas that are currently cropland, and you see in reddish the areas that are most likely under a middle of the road scenario going to be cropland by 2050. This is grazing areas. I'm not going to explain too much detail. This is forestry areas. That's interesting to see. So in green are still areas that are forested by 2050, but you see in orange here the areas that are going to be deforested, basically, which are currently forested but are not going to be forested anymore in 2050 under this middle of the road scenario. So you're able to point to specific areas where you're likely to see specific changes in land use, which could really inform national policy debates or national policy making. And I said, okay, these are regions what we want to focus on, perhaps because of biodiversity, which is particularly important, but we are likely to see degradation there, or likely to see land use change there, so we want to put a bit more effort on that. And then we had the national angle, and we had help from the Kenyan UNCCD focal point, or the ex-Kenyan UNCCD focal point, Richard Mondendu, who did lots of work of reviewing basically all the policy documents for the both countries, and we realized that the policy goals set in both countries are pretty ambitious. So Ethiopia, for example, have large commitments for improving productivity of croplands, etc. But they are, and in principle, they're aligned with the most optimistic scenario that we put forward. So the SSP1 scenario, that's called. But in practice, you see that the current trends and the future scenario, or the current trends, are much more pessimistic, much more. Too much talking. So the policy ambitions were really, or the policy goals were really at the most ambitious scenario on SSP1 scenario, but trends were focusing on the more pessimistic scenario. So there's a clear discrepancy that we identified basically from the from this exercise. So some key messages I want to highlight. The initial question was, can these be downscaled, these scenarios? Yes, they can. I think we shown, or we did that basically, and that was we were able to inform national policy debates. I would highlight that in this exercise it was critical, or very nice, to have the active engagement of a number of scientists and government officials in both countries, and I would particularly highlight the involvement of KEFRI in Kenya, who were very helpful in setting up this exercise. And basically, yeah, this approach allows for data downscaling to lower levels, to regional level, even to grid level. It allows to understand where trade-offs between certain policy goals may arise and how to address them. Basically, you can highlight gaps between stated policy ambitions, trends, and scenarios, and see where these gaps emerge. And as such, provide a framework for exploring new policy options and the effect of those policy options. So I would like to stop here by saying I think this pilot can be extended or rolled out in other countries and other settings, so we'd be happy to contribute there. And that's all that we had wanted to say at this stage. So fortunately you're still here, Baron, to maybe to share some thoughts, and then Eli as well.
So you can tell that he's from the Netherlands because he didn't miss a beat when the rain started. So let me make sure I don't repeat what I'd said in the previous one. 1 second. One sec. Okay, so we began this session is where we focused on the scenarios, or our speakers focused on the scenarios, and I think it was very evident even from the initial slides that we have trade-offs, and you know, we have, as I said in another session, we have multiple train wrecks headed to the same station, right? So they spoke of only some of them, but they're the big ones, right? If we're going to try to balance nature and food production, you know, most people, when they hear that, they think about nature as something to protect, but we have to recognize that nature provides many, many ecosystem services. So there's a lot that is at stake here. The effort here was to look at business as usual. I would comment it would be nice to also look at some of the other scenarios if we move in, you know, the better direction, but at any rate, and it also pointed out that if we look at that, we're going to have an area the size of India in terms of land conversion. And I would make an argument, if this COP does nothing else, it should send the message to the world that there should be no more land conversion, because we're not going to solve anything if we don't stop that from happening. We also noted that, let me see if I can get this note correct. So they added into the scenarios the reality that in the past we have had steadily increasing crop yields through intensification and other methods. But they also noted, particularly for some regions, that the climate change impact is going to limit this potential. In fact, in some regions it looked like it was going to go the other direction. The business as usual, wait 1 second. So the business as usual, we're talking about soil carbon of 32 gigatons, or 3 to 4 years of current emissions, if I got that correct. And biodiversity, and I don't remember if the 6% was up or down. I think it was down 6%. So that's sort of the trend that we're talking about here. And when they then pursued the restoration scenario, what I liked about this was that we're talking about looking at where degradation has occurred based on their assessment, and then looking at the different relevant types of restoration in those locations. And again, we're assuming that the yield, the negative yield, can be reversed in this, and we end up with a significant improvement as a result of restoration, with quite a large difference across regions. But the big change comes when we bring protection and restoration together, which of course in this convention is required, right? If you cannot pursue land degradation neutrality without employing the response hierarchy, where you start with avoid and then you move from there through SLM and then all the way to the much more expensive and challenging restoration. Now, for those of you in the room that apply this in other conventions, you use a mitigation hierarchy, which includes offsetting as an option. In LDN, counterbalancing, a different term on purpose so it doesn't get confused with offsetting, is just an accounting measure, right? Because we're talking about doing this at a national level. So you're looking at, are we actually going to make it? We're not looking at actually using that as an option. Maybe, let me put it another way, if we got to that point, it would be a good complaint, because we were actually doing a lot on the ground. We're nowhere close to that now. So it was made very clear that the trade-offs of ecosystem protection and the risk to food security are very real going forward, which again is an argument towards a framework like LDN, and in particular integrated land use planning, so we can better optimize what we do where. And I think the other take-home message is that is that restoration and protection are not enough if we're going to bring in the climate change part of this, that emissions must be reduced. And I guess I tend to word it a little bit differently, that all of this restoration and protection is where we're putting the carbon back where it belongs. But we have to stop putting it in the atmosphere. So in other words, if we word it in one way, it's one or the other. But really, we need both, all the time, everywhere. In addition, there was a presentation of downscaling this, so we could look at this at a regional and even country level. It was a challenge that they were put to, and they pursued this challenge in Ethiopia and in Kenya in a participatory way, at least with governments, and if I've got it correctly, with local scientists. I wasn't sure if that was the case. Okay, so I think that's important. I think that in the future we might want to consider also bringing in civil society, because I think you could get a lot of perspective from what's going on the ground there. And I guess the only big question I had is, did it have an impact? Did it influence action in those countries once they saw the results? Or maybe it's too early to know that, but I sure hope so. That's my quick summary of everything that was presented in the second half of this session on restoration and commitments and scenarios. Thanks.
Thank you, Baron. I would just add a few words to complement what Baron has said. I was involved in the Eastern Africa scenario study, and it all started in Ordos at COP13, where the chair of the Africa group came and challenged us and said, okay, these scenarios are good, they're interesting, but they're at such a global scale. How useful it is for us at this country level. Can you have a project or an initiative to adapt these scenarios to the regional and national level? So it took a lot of work, and then because it's not straightforward, I'm not the modeling specialist, those guys are, but we took up the challenge with the European Commission Joint Research Center, and we did the study. Now, one good thing about COVID is we were planning to have 2 workshops with the national governments in Kenya and Ethiopia and scientists, but then we did an online working group. So we were meeting with these scientists every month. We were having sessions, and they found this tool, these scenario studies, very useful to inform the policies. Now there is a huge capacity building needs. I mean, this was to introduce the concept. It was using scenario analysis to inform policy making on sustainable land management at the country level. And people in the government were very impressed, especially when we're discussing with them regularly all the results we've seen, and they had an input, because these scenarios, you have global data sets, and they're not accurate enough at the country level. So the main contribution of the nationals is they complemented the global data sets with their own data and their own policies. We analyzed current policies on agriculture, on forestry, and we compared these scenarios with existing policies. Of course, we found out that the governments have all the good intentions, and their policy ambitions are in line with the ambitious SSP1 scenario, but the current trends are in line with the SSP3 scenarios, which is high land conversion, high land degradation. So it was a very good, I think, study. It was very well received, and the request now is to, because this modeling was done by the colleagues in Holland and the colleagues in ECGRC, is to move this, if can we as UNDP provide the funding or support to move and do the actual scenario analysis by the nationals at the local level to make this as a tool for managing trade-off and better informing policy making. So the impact we're opening the door. There's big interest. There's request for further support, but we need to keep working on it. And complementing the global data sets with national input is, I mean, the main is very useful. Thank you. Yeah.
Just one small comment, and really what you just described is music to my ears. Let's look at climate change. We've been projecting climate change for decades now, and we even have those projections for biodiversity loss, but we've never looked at land degradation in this way, and we've never looked at restoration in this way. So when the Jeff and Carlos Manuel, it's a very big issue. When they're talking about policy alignment and dealing with disincentives, et cetera, which is a very, very important thing, this makes it possible to actually know what the influence of that alignment would be. And that, I think, has never been really put on the table for countries. They just hear align your policies, but they don't necessarily have the tools to evaluate them in a way that would show the potential impact. I think this is fantastic. Thanks.
Thank you, Baron. And if any questions, we'll take a few questions because before we wrap up.
I would like to thank first both the presenter for their nice presentation. Actually, I have a small query for first presenter, though I have missed some of the slide at the beginning. In a slide, you showed that assisted natural regeneration helps land degradation, land restoration. Actually, you know, when a land is degraded, profuse natural regeneration is not possible there. My question is how assisted natural regeneration helps in land restoration. Thank you.
Yeah, and then we'll get to the second question there. Thanks for your question. As I understand it, but I do have to be a bit careful here because I'm not, I'm a modeler. I have my limitations with knowledge on the ground, of course. But we have these two options basically for the forest and degraded forest areas. And it's either forest plantations or natural regeneration. And of course, there's a big divide there. So as I would interpret this would be natural regeneration, but it's not that you just wait until something happens. It is assisted. So it would be local species, endemic species, making sure that they can survive their first years, even though the soil is not so good anymore, and then hopefully, as soon as possible, in a more natural way, regenerating. So it's not just wait and see what happens. That's not the case. So that's the idea.
Hi, another question here.
Okay. Yeah, please go ahead.
I'm concerned that you didn't put in the impacts of human destruction. You had climate. Does climate cover humans? Because the big commitments you showed in the first presentation, a lot of greenwashing takes place because some of those politicians are actually destroying the lands. You know that, right? And each year we have over 200 environmental defenders being killed. So it should be important enough that that aspect is in the model. Okay. So I hope your further modeling will include the numerous damages being done by investments. If you want to really attract the people, real-life situations, you have to include these things. The people-centered things. Another thing, you had discussions with something and governments. We're the people, we're the local people that's gonna make the change. So these are just some observations.
Thank you. Okay, we are almost done. We'll take one more question and then I'll give Jonathan here. Yeah. Because we're running out of time.
Thank you. So Ezra, you were right about it being an information overload. So It was fantastic, though. So, yeah, I think one of my questions is more technical around your decisions for separating grassland from rangeland in the one thing. So I'm actually looking forward to just reading what you have been working on, because it was a lot to take in. And then just something that you could maybe look into, UNDP and the UN Biodiversity Lab did a mapping nature and people last year, and it's mapping of essential life support areas, where we in a participatory process looked at spatial data and information and intersected that with policy commitments within South Africa. And that process was actually repeated in other countries like Cambodia, I think Zambia. So you can look into that, because it was just a really fascinating process to be part of, because then we together prioritized 10 policies that needed to be worked with, including land degradation neutrality, looking at the CBA priorities, biodiversity priorities. So yeah, just something to look at, because then we went through a systematic conservation planning process where we then identified where across the country at quite a good scale actually, where we can protect, manage, restore and urban adapt. So just something to look into. It was a fascinating process to be part of.
Okay, I'll give.
Thanks for these observation and comments, I guess, mostly. Just wanted to quickly respond to you. You're fully right, but I think this is also a key thing with this global modeling. It's so big. We do have these factors in that we're talking about SSP1 and SSP3, so that's basically a world where there's more environmental awareness versus very little, so these large-scale destructive investment. So we try to take it into account a little bit, but very limited. So that's where you really need more local studies, and they also get the more local people, the civil society, anyone into account. And that's, yeah, thank you for your observation, would be of your suggestion. Yeah, I think it would be good for us to have a look there and see what we can do with that. So that's great. And maybe one final thing. Yeah, I want to thank you all for staying here for so long. It was very interesting, good discussion. And I just wanted to highlight quickly our theme site that we have about nature-based solutions, where a lot of our work that we presented today, but also other work from PBL looking at more integral solutions is presented. So this is a very modern link that was also shown by Wokat, similar, right? So that's nice that you can use it. So thank you so much.
Great. Okay. Well, thanks, everybody. So there is still one more event yet this evening for Land Degradation Day, starting, gosh, in about 10 minutes. Might be a little bit later here. LDN reporting, target setting, and monitoring. We'll be seeing experiences from Ecuador, Turkey, and Kazakhstan. They're going to be looking at how they've co-developed and applied the tools developed by FAO and WOCAT at the national level. So take a bit of a break, stretch your legs, and this next thing will start very, very soon. And so if the organizers are here for that, I'm glad to have them come up and we can set that up. Thank you very much. Ladies and gentlemen, we're going to start the event in just a couple of minutes. So if you would take your seats, and I would invite the panelists to come up to the table as well so we can get started. Thanks very much. Okay, ladies and gentlemen, let's just get started. Everybody at the buffet and at the back of the room, just speak quietly. We're starting our last session here of Land Restoration Day. We're going to be looking at national examples of LDN works. So I'll turn it over to the panel. Ingrid, it's up to you.
Thank you very much. So it's a pleasure to be here. Thank you for attending on the last presentation of the day. I would like to give the floor first to Pablo Casa for the opening remarks.
Thank you very much, Ingrid. And on behalf of the Ecuadorian government, I would like to welcome all of you for being taking part of this side event. As all we know, land degradation occurs at subnational and local levels, as well as adaptation to climate change. And for that reason, our land degradation crisis requires fundamental societal transformation in our economy, laws, policies, and agriculture practice. We believe this side event is a kind of platform where we can share our experience about how we are addressing monitoring and assessment land degradation in different contexts, obviously. How we can put on the table that data and the information necessary for decision makers. In the following presentation, we are going to see very interesting experience from countries as Turkey, as Nicaragua, and Ecuador as well. And I think this is a great opportunity to get some feedbacks from all of you that could be useful for the next prize report. Finally, I would like to thank to FAO and especially to WOCAT for making this side event possible. Well, WOCAT has been a very strategic partner for Ecuador in this convention. And it's important to share with all of you that we have been working with WOCAT in many initiatives, for instance, the dissemination and systematization of sustainable land practice and technologies, even the development of the web app that later I'm going to show you. And well, we hope to continue this collaboration with WOCAT and FAO in the future, because we, as a Ecuadorian government, we will have great challenge relate to our LDN target setting. Thank you very much.
Thank you, Pablo. I will be moderating and presenting at the same time. And so I will start with an introduction, a brief introduction on the co-development of these LDN decision support systems and tools that we've been working together with FAO and WOCAT. I work for both of them, so I'm happy to say I'm part of the WOCAT Secretariat, and I'm also part of FAO as an international consultant on LDN and SLM. So with both institutions, and a lot of the work we do is related to sustainable land management. And I think it's important to mention how key sustainable land management is to create synergies, and how it is important to achieve not only the LDN targets, but also related to climate change and conservation of biological diversity. So really SLM can support the objectives of the 3 Rio conventions, and we are in the Rio pavilion. So we have a lot of knowledge on SLM, and we know that WOCAT is the recommended database on sustainable land management practices, and we have not only knowledge but many tools, not only the WOCAT database, but what countries need to know is where to apply and how they need information to make informed decisions, for example, of what to do where. No, that is the big question that when we are working in a project, when we are trying to achieve LDN, to design our interventions is, well, where should I do and what? And this is very important to achieve LDN. No? We know that with LDN we need to balance our losses of natural capital with our gains, And we need to make this a step of going and work at the landscape level. So for that, we need to map land degradation and sustainable land management. No? So this is a big challenge. And what for? Why do we need to map land degradation? Well, you probably know this better than me, but for many reasons. The title of today's talk was about target setting, monitoring, achieving LDN. So mapping land degradation is key for all those things. We need to know where degradation is, for prioritizing areas for intervention, to report to UNCCD, to monitor land degradation, and for example, integrated land use planning and so on. But something also very obvious, probably to all of you, mapping land degradation is not easy. Degradation is a process, no? We know, for example, if we want to map forests, it's already very difficult. We have many different forest maps and they do not all agree on where the forests are. Imagine to map land degradation. It's a process, causes change in space and time, and and something very important is that estimations need to make sense across spatial scales. And I always quote the World Atlas of Desertification that says that land degradation cannot be globally mapped by a single indicator or through any arithmetic model combination of variables. But still, we need to estimate the proportion of land that is degraded, to estimate our indicator for SDG 15.3. And we have a lot of tools, and we have the good practice guidance, for example, from UNCCD, and we know that we need to map these 3 sub-indicators, no? Trends in land cover, trends in land productivity, and trends in carbon stocks. And I think it's interesting to note also that even in the good practice guidance, we have this acknowledgement that it is very difficult for a single indicator to fully capture the state of the land, no? So how can we improve our estimations? And this is something we are working with many countries through different projects, because countries want to map land degradation in a meaningful way. And there are many ways to improve our estimation of the sub-indicators and the final SDG 15.3.1. One of them is choosing the best available data, and for this we always try to integrate national data, which is usually the best. It's validated. You need to explore also different algorithms to make calculations, because data is malleable, and depending on how we analyze the data, we can obtain different results. So it's important to explore and see what fits best to our reality. We need to integrate knowledge, expert knowledge, through participatory processes. And it's something also very important is to estimate the uncertainties, or at least acknowledge which are the limitations and what needs to improve. I always like to provoke the audience with this slide. So are we going in different ways? Are we, our resources and our work to report, is it going the other way to achieving LDN? And we certainly hope not. And this is what we are working on, trying to align and using methodologies that are meaningful at national level, but also at subnational level. And that if we know that we have 30% degradation, find a way to actually see that in our maps and report that. And to achieve that, we are working with this concept of convergence or convergence of evidence. This was also mentioned in the World Atlas of Desertification and proposed as a way. And convergence of evidence is a principle in which we need to find accumulated evidence that tells us that in the same place different issues are coexisting, and that that way we can have more certainty that there is degradation occurring, especially for making decisions and actually achieving LDN and prioritizing areas for different types of interventions and so on. So with the work that we are doing, we are using additional indicators in addition to the 3 sub-indicators for SDG 15.3.1, like related to fires, livestock density, to soils. Many countries have information on soil texture, on soil erosion, on salinization. Also to enhance our synergies with the other conventions, we are using data related to biodiversity and to climate and so on. So with this convergence of evidence idea or principle, we are trying to link what the amazing information I always say this is a time of opportunities in terms of data availability at global level and also regional level, with the local data and expert knowledge. So how can we actually do this? How can we integrate knowledge using the principle of convergence of evidence? Well, we are doing this by co-developing. This is the first word in the title of today's presentation, co-developing. We are Ecuador, Turkey, Kazakhstan. We'll show you examples of a similar tool, but that is not that fits all, is the same in all the countries. It was because it was co-developed with each country. And for example, and these tools that we will show you today are basically Google Earth Engine applications. They are cloud-based. Each country and stakeholder define which issues they consider important to map, which are the best data sets and methodologies. They use their knowledge and experience, and we get the feedback, and it's a constant development trying to adapt it to the end user needs, which is the country. So here you have 2 links where you can also see the galleries of applications that we've developed. And here I would like to mention that Turkey was our first country in which we started developing this tool, and it has expanded to more than 20 countries already, such as Ecuador, and not only in Latin America, but also in Central Asia, in Africa, and so on. So the tools have mainly three functionalities, but Suna will talk about them, so I will not spend so much time with that. It's also important to notice that each of them have different tools and different purposes, and was born on a different need. For example, Ecuador, you wanted to compare different assessments, qualitative and quantitative assessments of land degradation. Turkey really needed a tool to make decisions to achieve LDN. Kazakhstan, they wanted to compare different maps to choose the best ones and integrate their national knowledge and so on. And this is an example in Colombia that I'm also taking the opportunity to invite you to our side event tomorrow with Colombia, where we will, in which we also integrated the information from Price4, the default information, the trends.earth information with WCAT database and information on sustainable land management, and their national information on soils. So I will leave the floor to the main speakers of today, which are Ecuador. Pablo is in the contact group, so it seems that there is a big negotiation happening. Can you speak, Pablo, now? Or yes, good. So Pablo from the Ministry of Environment, Water and Ecological Transition of Ecuador will start with Ecuador's experience.
Okay. Hello, everybody, again. Well, right now I'm going to present to all of you an experience related to a web application that we generated with the support of FAO and WCAT, and that aims to be a tool that guides the establishment of the sustainable land measure and allow, avoid, reduce, and recover degraded lands. As well as the prioritization of programs and projects within the framework of the formulation of neutral degradation goals. In spite of that, well, our territory possesses 4 bioregions that produce, that enable conditions the enable conditions to create some complex landscapes and ecosystems. And it's common find many mosaics of agriculture and ecosystems with the high ecological values and socioeconomic challenge from, for instance, high poverty and low income. Well, okay, right now we are seeing one of the, thank you very much. Right now we are seeing one of the outcomes that we develop relate to the national assessment of land degradation in Ecuador, and according with this information, approximately 19% of the continental territory is undergoing strong and extreme process of land degradation. The province of El Oro, Esmeraldas, and Manabí are the most affected ones. It's important to mention that there is a linkage between land degradation and change in land use. Land degradation occurs in agriculture zones, forests, and other key ecosystems in this province. Okay. On the other hand, as we have spoken in this COP, drought is one of the biggest concerns for all the countries in Ecuador as well. In this slide, we appreciate one of the key information that belong to the National Plan of Drought of Ecuador, and it mentioned that around 16% of the Ecuadorian territory is under a high and medium susceptibility to drought. The province that are the most prone to drought is Manabí, Guayas, and Loja. Okay. With this general vision, we can conclude that the coastal region of Ecuador is carrying with the greatest challenge related with land degradation and drought. The Ecuadorian government saw the need to apply LDN approach and its principle. For that, it's important to know that we also see the implementation of sustainable land management that allowed us to avoid, reduce, and reverse land degradation as an opportunity to find some benefits with the adaptation to climate change in the agriculture and livestock sector. So we must be ensured that that information is available to the decision makers and a small farmer as well. For that reason, we developed this web app that is in a beta version. Right now, we can see this beta version, the interface beta version of this web app, and we have the access link too if you want to go there. Okay. So what kind of information does this app contain? Well, it contains the following. The National Assessment of Land Degradation of Ecuador that was developed in 2018. The second information that the web app has is the hand-in-hand initiative. And the third one is the national set of land cover and land use, soil properties, and hydroclimatic indicators. And finally, we have in this web app global satellite derived the LDN indicators such as land productivity dynamics. Okay, we will briefly see each of these information described above. The first one is the result of the participatory land degradation assessment based on expert acknowledges questionnaire Following the land degradation assessment that its name is LADA, and the word overview of the conservation approach and technologies methodology. We have in the present slide we have 4 of these outcomes that we obtain by the application of this methodology. The second kind of information is this is related to the hand-in-hand initiative, and that is a typology of maps based on poverty maps and estimate agriculture potential and efficient scores using household surveys on agriculture production. The third one, in this point, there is another information available, but specifically showing to you this indicator because for my country, soil organic carbon also represent a point of synergy with adaptation and mitigation to climate change, because on the other hand, the estimation of organic carbon soil can provide us to some indicators about the state and the conservation of the ecosystem service, and as well we can estimate the effective the reduce or the potential reduce of the greenhouse emissions. Finally, we have the dynamics of land productivity. This is a land degradation indicator, and is being considered one of the less advanced in Ecuador. However, we have scheduled a series of workshops with experts for this and the following year in order to adjust and validate the inclusion of this information in the next price report. And one of the greatest advances that we had in this application has been that through it we can obtain certain statistics that allowed us to spatially locate and prioritize sustainable land management action or solutions at national and subnational levels. Here we can see an example of that I mentioned. In the lower left graph, we can see the content of the organic soil carbon in function of the land covers that our country has. And finally, this is a roadmap. Sorry. As you may have seen, the application has the web application has different sources of information, and specifically, there are 2 inputs that directly contribute to the determination of land degradation. These are the 3 indicators of the price report relate to land cover and use, organic carbon soil, and land productivity. And on the other hand, there is information from National Assessment of Land Degradation that used the LADA WOCAT methodology, which was based on consultation with experts and land degradation at national level. It's important as a conclusion of all this presentation. All this information we are going to include it to the next price report and the LDN target setting. Thank you very much. I'm open to receive questions about my presentation.
Thank you, Pablo. I don't know if there are specific questions for Pablo or me. If not, we can continue. I don't see any hands raised. So our next presenter is Suna Morkok. Suna is a forest engineer from Turkey. She works in the General Directorate of Combating Desertification and Erosion. We have been working with the CHEM for a long time, and she will present also their experience, and I can say that Turkey was where this was born, and we're happy to see it being outscaled to many countries. So Suna, the floor is yours. Thank you. You wanna
Good evening, everyone. I would like to thank you for taking your time and joining us today. I'm Suna Morkoj. I work for the General Directorate of Combating Desertification and Erosion under the Ministry of Environment, Urbanization, and Climate Change. And today, I'm going to be talking about integration of national indicators and monitoring systems to achieve the LDN, LDN in Turkey. As you know, LDN provides significant benefits in terms of adaptation to climate change. Reducing or reversing land degradation can transform land from being a source of greenhouse gas emissions to a sink by increasing the carbon stocks in soils and vegetations. Furthermore, LDN plays a key role in strengthening the resilience of rural communities against climate shocks by securing and improving the provision of vital ecosystems. I wanted to briefly mention the LDN objects here. The objective of LDN is maintaining the sustainable delivery of ecosystem services and improving productivity to enhance food security and increasing resilience of the land and populations, and seeking synergies with other social, economic, and environmental objectives, and also reinforcing responsible and inclusive governance of the land. As also Ingrid mentioned, in 2015, COP12 was hosted by Turkey under the presidency of Turkey. Following this, Ankara initiative was launched to help developing countries actually achieve their LDN targets. As you see on the screen, Turkey also set its voluntary LDN targets, such as to increase the forest area, to improve productivity in forest land, pasture land, and agricultural land. To achieve our land degradation neutrality targets, we need some decision support system. Decision support system is actually a computer-based systems that enable decision makers to make accurate and effective decisions with integrated data and models. And LDN project also has some approaches like strengthening the enabling environment for LDN and multi-sectoral land use planning processes in Turkey, and development of decision support system, achieving LDN on the ground, and also upscaling and monitoring LDN. LDN has 3 indicators, land cover, land productivity, dynamics, and also carbon stocks. But in Turkey, in addition to that LDN indicators, we build some national models and inputs, such as watershed monitoring and evaluation system. We produce dynamic erosion monitoring system and Turkey desertification model, soil organic carbon model, collect earth for land productivity, and also like national land use and land cover model. I wanted to talk about our desertification model like briefly. We built our desertification model and vulnerability map by using like 7 criteria. As you see, like under these 7 criteria, like we use like sub-indicators, and each of them has like as you see, like each criteria has the weight in the model like as percentage. We experts and with the experts, like we set up, we describe the weights like for the model for every criteria. And also we produce soil organic carbon model and map, and to estimate the soil organic carbon amount like in Turkey, and develop a system to monitor the change in carbon amount, and also to conduct activities to protect and increase the current stock. And what, according to like our map and model, and Turkey has like 3.5 billion tons of carbon, like in 3.5 billion tons carbon. So why we need DSS? DSS is like really important for us because like I just mentioned like our national models and national maps. Of course, like each of them, you know, like serves for different like projects and different subjects. But what we wanted to do is like we thought like how we can integrate those models and inputs into one system so that we can do like multi-criteria like analysis. First, here, yeah, this is the beginning of like DSS, and while I'm here, like I would like to thank Ingrid and FAO like for continuous support. So we started building DSS in one of the basins in Turkey. It's called Upper Sakarya Basin. Turkey has 25 hydrological basins, and Upper Sakarya Basin is like one of them. So we started here first, and then we integrated for the whole Turkey. And each indicators was improved for better results. So Ingrid also mentioned the importance of using national data. So I wanted to show you what's the difference between using national data and also like the global data. Between like national data and the global data. So on the left side, you see the global data, and it shows like Turkey soil organic carbon stocks, like approximately like 2.7 billion ton carbon. But when we look at our national data, it's actually like approximately 3.6 billion ton carbon. And when we produce like these maps and models in Turkey, we also like conducted our verification studies, so it's like a more accurate comparing to like the global data. And also here, another example like about the protected areas, and again like the global data shows Turkey has 195,000 hectare, approximately 1,000 hectare protected areas, but our national data shows it's actually like approximately 3.5 million hectare. From GSS, we can get results based on like the basins and project pilot areas. Again, like hydrological basins, sub-basins, and also like provinces and districts. I might need help here because, sorry, just give us a second. Yeah, that one.
If I may, Suna really likes to show the DSS live, and we think it's much better than static pictures. So you will see it working. can we do this? Yes, we can. So this is the link to Turkey's DSS. Now anyone can access through this link and use all the functionalities. There it is.
Right. Perfect.
Thank you.
Thank you. Thank you so much. Yeah, we don't have mouse here. It's going to be a little bit difficult, but I'm sorry. So this is the Turkey DSS. You can choose, of course, like the language on the left side. Oh, yeah, that would be great. Thank you. Yeah, on the left side, yeah, you can see our layers here, like mostly our national maps and inputs here. And here, that's the important part also, like you can choose like which area you want to work in. So let's say like we wanted to work in the basins, like one of the basins. When you zoom in and then click one of these basins, so it's on the right side, system automatically like calculate like those numbers, those information, like based on the area you chose. So yeah, I already like mentioned those layers, like how we produce them. I wanted to really highlight like that part, like multi-criteria analysis here. We have a simple and also like advanced part here. In simple part, you can see LDN indicators, and advanced part, what you can see is like we added here like a lot of like layers, like mostly are like a national models, national maps, so that we can do like multi-criteria like analysis. Just a quick example to show you how the system works. For example, when you describe the system to show us the early sign of decline in land productivity dynamics, and also the declining land productivity dynamics in cropland in this specific area. And system, when you calculate this, like system calculate this like 53,000, approximately like 54,000 hectare here. When you zoom in, you can see like these areas like in the purple color. Like when you want to focus like where these areas are, you can zoom in and then easily like see where they are. And also, yeah, on also the right side, you can see the information as graphs like here and like a table. When you click this, like you can see a table here, and also this shows like for each type of like each land use type, you can see the land productivity, how land productivity changes, and you can download this data from here on the right side. Why that part is important, I'm going to be sending this like in my presentation later on. So another part which is important, I would like to show you like that land cover transition here. So what that gives us is actually like we have like according data here in 28 years, system shows us like how the land cover actually changes in Turkey. Let's focus on like some area. For example, yeah, this area you can just choose like just one color here so that you can see the transition. For example, like, yeah, that yellow area, like when you look at this, it was a cropland before, but now like some of them is like it transitioned to tree covered, and the area which was like a tree covered before, like here in this area, in 28 years they transitioned to, actually some of them transitioned to like the cropland, and some of them like transitioned to like a grassland. And this is just the visualization of the data, but if you want to look at the numbers numbers for that land cover change, again you can click that one, and you can see from what land type what land use type to what land use type, we can see the changes here. This number, like, in this matrix, the matching, that one shows like the area which we don't see the changes, but this one means, for example, 104,000 hectare area from tree covered actually transitioned to grassland, and again like 137,000 hectare area transition from tree cover to cropland. Like such the system works like that way, and you can also like download this again like from here. Download the data and numbers from here. And the last part I would like to mention is like a drawing tool. System allows you to actually, draw your like the own project area. For example, just randomly, I wanted to show you like this. When you draw your area and click this, when we go up, system again for this area calculates all the numbers and information, and you can see like here, you can see the numbers based on like this area, and the tables like here as well. So this is all for the application part. So I would like to go back to presentation. Thank you. Thank you. So hopefully like, you remember the part like that we can download the data on the right part. What we can do is, for example, recently we started a study. Right now we are preparing our strategy and action plan for each provinces based on like a decision support system. So we download the data with my colleagues, and we work on those data to produce like the such graphs, and also like to produce like tables like this. So the system allows you to like work with the data like however you want. And another importance of DSS is we are going to be using DSS for LDN related reporting, and also like this year we are going to be reporting for price 4, and we already started working on this data and the results from decision support system, and we believe and it's going to be so helpful for Turkey to successfully complete this reporting process. And in my last slide, I wanted to again like highlight why decision-making process is important, because the aim is to inform decision makers about the current LDN status and support decision makers to analyze the advantages and synergies between different land uses and practices, prioritize the intervention areas for avoiding land degradation by taking measures as well as reversing the degraded lands through rehabilitations, and also contribute revising the targets on LDN. Thank you so much. Thank you so much for your patience.
Thank you so much, Suna. Suna was showing the land cover transitions, and after the COP, we are having a land cover transitions workshop in Turkey to actually discuss and define which of these transitions can be considered degradation for Turkey at different contexts and which not. And with that information, which will be a participatory workshop with 80 people we are inviting from different stakeholders, we will feed that information to the decision support system and will be used for the price for report. So our next speaker is not here, as you can see. And so we will play a video. This is a challenging meeting for the technical team. We are changing all the time. Thank you very much. So Mr. Murat Temirsanov, he is the chief of the Committee for Land Resources Management of the Ministry of Agriculture of Kazakhstan. He's the UNCCD focal point, and they prepared a video for us to show how Kazakhstan is monitoring land degradation neutrality and how they are using these tools in a different way. We've seen Ecuador, they will use it for the target setting, Turkey as a decision support system, and in Kazakhstan we also use these tools with different purposes. So if, thank you.
Good afternoon, everyone. Distinguished colleagues, guests and organizers of the United Nations Convention to Combat Desertification, Conference of the Parties, and distinguished participants of this side event. Allow me to greet you on behalf of Mr. Murat Temirsanov, UNCCD National Focal Point in Kazakhstan and the Ministry of Agriculture of the Republic of Kazakhstan. I would like to thank you for giving me the word. Unfortunately, I was unable to join you in Abidjan today, but I am happy to participate remotely. Today, we have gathered here to remind ourselves once again of the importance of land monitoring, especially the state of soil resources, as they play an important role in preserving ecosystems and ensuring the growth of people's well-being. Kazakhstan joined the Global Land Degradation Neutrality Target Setting Support Program in May 2017. Since then, certain efforts have been underway, which I will share further on. Today, I will present brief information on the state of soil resources of Kazakhstan, on ongoing activities to combat land degradation, using GIS tools in collaboration with FAO Kazakhstan to map the results of soil surveys, and on further steps of Kazakhstan to restore degraded lands. The Republic of Kazakhstan is blessed with abundant natural resources, such as land, with an area of more than 272 million hectares, and as everyone knows, ranks 9th in the world in terms of area. Agricultural lands occupy 40% of the country. Here, it is worth noting that the state of the soil, namely its fertility, plays one of the key roles in the effective management of agricultural production. Unfortunately, according to soil surveys, more than 90 million hectares of land are eroded and erosion-prone, of which about 29 million hectares of agricultural land are actually eroded. As of 2018, more than 35 million hectares of land are saline, and about 17 million hectares of rangeland resources are degraded. As we work to implement sustainable land management approaches, we also face various challenges, such as obsolete data that needs to be updated immediately, but it takes more than 1 year and a lot of resources to cover the whole area of the country. When fighting against degradation processes, it is crucial to be aware of all soil changes and identify their causes. Only by having up-to-date data on the condition of soils, we can talk about sustainable soil management and measures to restore it. Current fundamental soil surveys help to create a set of soil maps with soil features, as well as to develop recommendations for their rational use. In 2017-2021, the government ordered a soil survey of 33 million hectares and a geobotanical survey of 33 million hectares. The soil bonité scores were determined on a territory of 25 million hectares. According to this data, more than 36 million hectares have been digitized. Of course, these are not exactly big numbers, and in order to speed up this process, various GIS and remote sensing tools with further verification of the data by experts in the field are coming to help. Already now, in partnership with the FAO Kazakhstan office, various properties of soils are being mapped in Kazakhstan. Thus, in collaboration with the FAO and WOCAT team, a national geoportal for Kazakhstan was created, which also includes a soil salinity map of Kazakhstan, land productivity map, drought map, and map of organic carbon stocks in the soil. As everyone knows, land degradation depends on many factors: drought, soil salinization, wind and water erosion, water scarcity, and many other factors. The GeoPortal considers a set of 3 on-the-ground progress indicators adopted by the UNCCD, which are central to reporting progress toward land degradation neutrality. These are vegetation trends, trends of the land productivity or functioning, and trends of carbon accumulation above and below the ground. The land productivity map of Kazakhstan was developed with the Google Earth engine by the FAO and WOCAT team using space data with further data verification by 12 experts of the Land Resources Management Committee of the Ministry of Agriculture of Kazakhstan. The experts were given a choice of 4 different maps with corresponding descriptions and questions to do their further validation. I believe that this process will be continuous and the map will be under constant improvement. A soil salinity map of Kazakhstan was developed with the FAO support as part of the Kasilum 2 project. Initially, the FAO methodology training was provided to the ministry staff, and it was piloted in 4 regions of Kazakhstan that already face secondary soil salinization. After that, a national salinity map was drawn up on the basis of data from nearly 8,000 field locations that were surveyed from 1967 to 2021 at soil depth from 0 to 30 centimeters and 30 to 100 centimeters. As can be seen from the figure above, according to the topsoil survey, salinization covers mainly irrigated lands in the south, southeast, and southwest of the country. However, data from subsurface analysis show that salinization covers both rain-fed lands and rangelands. Secondary salinization is the main problem of land degradation in irrigated areas of the country. The soil organic carbon sequestration tool presented today is the first participatory tool for the global assessment of soil organic carbon sequestration potential. Various information layers are displayed on the map, allowing users to visualize important data, such as available and projected soil organic carbon stocks under various sustainable land use and business as usual scenarios, as well as relative sequestration rates under each of the scenarios. In 2021, Kazakhstan faced an abnormal drought, which led to the loss of crops, livestock, and consequently the loss of income for the rural population. Therefore, it is very important to screen for agricultural drought and make informed decisions about preparedness. The FAO project consultants in Kazakhstan have adopted the Modified Combined Deficit Index, MCDI, to assess agricultural drought in the country using GIS and remote sensing data for the past 20 years. Agricultural drought is identified when yields are below normal due to prolonged moisture deficits in the root zone caused by deficient precipitation compared to the normal period. This indicates that the agricultural drought is more than 1 month long. Also, the NDVI does not respond immediately after rain. Therefore, the time lag between agricultural drought and meteorological drought is about 1 month in arid and semi-arid areas. By doing this analysis, we have a picture of the recurrence and risk of drought and can make decisions about preparedness. These maps illustrate the yearly occurrence of agricultural drought based on average data for May, June, and July, which are considered to be the most important months in agriculture of Kazakhstan. During the study period, 2001 to 2020, only 5 auspicious years could be observed, while all the other years agricultural lands of the Republic of Kazakhstan were prone to drought. Moreover, it was observed that the agricultural drought has the cyclical pattern of occurrence, which is going to be used for forecasting models and further research. The set of all land degradation neutrality measures plays an important role in combating desertification and reversing further land and ecosystem degradation, desertification and deforestation in arid areas. It is important to continue efforts in this direction, to introduce monitoring tools and ecological problem-solving approaches when combating desertification. I think activities such as the development of a geoportal and soil survey with further mapping of results, among many others, carried out in Kazakhstan to achieve land degradation neutrality will be a good example, which can be upscaled in neighboring countries with a similar institutional structure and socio-economic background. We can also support interested countries in this domain. In conclusion, I would like to express my gratitude to FAO Kazakhstan for working together and hope for further fruitful cooperation. Thank you all for your attention. All the best.
Thank you. Now it's the end of the first part, but the second part will be very brief presentations of Botswana. If the next presenters can come in, we will change because we were too many to be here. So I would like to welcome the representatives from Botswana, Lesika, yes, and Dr. Mohamed Luthor, yes, and Nicole. So, no, I will, yeah. Yes, and Bangladesh, please, Mr. Lutfur Rahman Mohammed. Yes, yes, yes. I'm sorry, I thought I said, come on. You can sit there, and I will, you prefer here? You can use this, yes. But you wanna? Yes. Yes, yes, yes. Lesika? You come here, please. Yes, we can put his name. Okay. Yep. So thank you.
Good evening. I think everyone is tired, so I'll take not more than 5 to 6 minutes. First of all, I would like to welcome everyone to my presentation, Assessing Land Degradation and Sustainable Land Management in Bangladesh, Challenges and Way Forward. This is Mohammad Lutfur Rahman, Deputy Secretary, Ministry of Environment, Forest and Climate Change. I have 2 other colleagues, Dr. Shohrab, is Director, Ministry of Department of Environment, and Mr. Mizan, he is Director, Department of Forest. First of all, I would like to give an overview about Bangladesh. Bangladesh has been among the fastest growing economies in the world over the past decade. Once upon a time, it was referred to as bottomless basket, but now the economy is 35th largest economy in the world, and it's on track to graduate from the UN's least developed countries list in 2026, and poverty has declined substantially. It is 14.3 in 2016. On the downside, Bangladesh is one of the most densely populated and climate vulnerable countries in the world. The economy is largely land-based, and agriculture sector is critical to the country. And sustainable land resource management is critical for sustainable and resilient development. Land degradation neutrality in Bangladesh. We have prepared voluntary land degradation neutrality targets, and these voluntary land degradation neutrality targets to achieve LDN by 2030 set by Bangladesh are: Target 1, improving soil fertility and carbon stock in 2,000 square kilometer of cropland area. Target 2, reducing land use cover conversion in 600 square kilometer of forest area. Target 3, to reduce waterlogging in 600 square kilometer area. Target 4, to reduce soil erosion in hilly areas in 600 kilometer square area. Target 5, to protect non-saline land areas from salinity intrusion in 1,200 square kilometer in coastal zone area. And target 6 is to reduce riverbank erosion 100 hectare per year, covering 100 square kilometer. The targets were based on the global data provided by UNCCD and were accepted as provisional and proposed to be updated with national data. You can see assessing and monitoring land degradation in Bangladesh. In the left-hand side, you can see land degradation neutrality target setting program. I will not elaborate it, you please see. And the right-hand side, testing innovative approach integrating CEPAL, SDG 15.3.1 indicator, good practices guidance, etc. Assessing land degradation for land restoration in Cox's Bazar. Cox's Bazar is situated in the southeastern part of the country, and you know it very well that 1 million displaced people migrated from the neighboring country in our country. That is the place. And so land degradation after massive refugee influx in 2017. And one regional and restoration plan was developed. SLM technologies identified and documented in accordance with WACAT. Geospatial lands suitability conducted for land stabilization, restoration, forest restoration, afforestation, reforestation, seedling distribution, habitat restoration, and nursery development. Monitoring land restoration using CEPAL SDG 15.3.1. We know that we'd like to ensure SDGs, especially 15.3. Now you can see that one spatial framework for environment and energy technical working groups here, a collaborative implementation approach for restoration activities involving more than 20 organizations. Technical specification of the restoration activities were prepared using WACAT. Guidance provided for planning, coordination, decision making, maintenance, and enhancing knowledge sharing between the different stakeholders, and remote sensing and geospatial analysis for planning and monitoring land restoration. You can see an example of land restoration plan map in one refugee camp in 2019. And right hand side, land degradation assessment using CEPAL SDG 15.3.1 module before and after restoration. And you can see that a map showing areas for which different organizations are responsible for land restoration in 2018. I would like to conclude here with giving a way forward. Importance of monitoring for learning and improvement. Field information is critical for validation, integration, etc. Remote sensing and geospatial technologies provides many opportunities near real-time, high spatial resolution, local level, big data, machine learning, etc. Institutionalization and sustainability for collaborative monitoring is critical for success. A continuous learning exercise and ecosystem restoration contributes to overall national economy and global environment. So thank you so much. Speech is silver, silence is golden. Thank you. Thank you so much.
Thank you, Dr. Lutfur Rahman. It is my pleasure now to. Are there any questions for Bangladesh? No? So our next presenter is Lesika Basalumi. He works is a Principal Forest and Range Resources Officer from the Department of Forestry and Range Resources, and he also works in FAO. So, Lesika, the floor is yours.
Thank you and good evening. So my presentation is going to be based on towards achieving land degradation neutrality, a case study of Botswana land restoration project. Botswana is a semi-arid country, and as a semi-arid country, we do have a problem regarding land degradation, and this results in decreased food production, prolonged drought, biodiversity loss. We've got a few, and decline in the quality and quality of forest and range resources, and at the end of the day, it affects the livelihood of the people. This land degradation is likely to be worsened by issues of climate change. And we've got some projects or planned initiatives which are going on in Botswana. But I would like to draw much of your attention to the last two. The last two referring to starting with the Botswana Sustainable Miombo Woodland Landscape Management, which is a GEF7 project. Botswana is actually delighted to be part of this child project of DSL, which is Dryland Sustainable Landscape Impact Program. So we are very much to be part of that. So this is one of the projects that is going to help us in issue related to land degradation. And we also have an ongoing project, which is the National Land Degradation Assessment, Monitoring and Restoration. And this one, it's a project which is supported by the government of Botswana. The government of Botswana actually contributed $1 million to support the project, while FAO supported the project through technical support, training, to make sure that this project is being realized. And the project, as I've already stated, it's as the project name dictates, it actually addresses land degradation issues. And the project components, the first one is the assessment of national land degradation status and trends. And this component was completed last year. The assessment was done and completed. And the second component regards the development of land degradation monitoring system, which my presentation is going to be centered around this component. And the third one, development of land restoration strategy, and finally setting of the LDN target setting. The monitoring and the setting of the LDN target are going to be one of the main issues for this presentation. And when you go further, we talked of technical working group, which actually did the rest of the analysis and data collection as well as analysis. And the plots which we assessed 5,794 plots under the African Open Deal Initiative, which were 10 kilometer by 10 kilometer grids in 2019. And we also assessed 11,535 plots, which are 4 kilometer by 4 kilometer intensified grids assessed across, as you can see the map there, the north-south eastern margin of the country, to support and provide baseline data for the national land degradation status and LDN target setting program in 2021. And then this, just to give an overview of the pictorial, how the project was carried out. We've got, we started with the project technical working group, which consists of experts from different departments which are dealing with land issues. And we also, under the technical working group, included the universities. We included the 3 universities. We took some staff from them to actually be part of the technical working group. And the Collect Earth advanced training and mapathons in 2021, which was facilitated by FAO headquarters. Those people, technical group people, were trained before they can start the work and assess the plots. And the LDN stakeholder workshops, we actually moved around the country to the districts, consulting the people, the local people, the NGOs. It was just a stakeholder consultation of many diverse skills from the local areas. We actually went to their district to have some workshops. And the field surveys, as you can see them. And lastly, we've got the LDN stakeholder meetings. So when you get to the key results of those assessments, this is actually the platform which I mentioned that is going to be the monitoring system. I had my colleague, she mentioned almost, when they were presenting, it was almost the same project, Google Earth Engine and the Open Forest Collect Earth were the tools that were used. And these are some of the results that shows that in one of the districts as portrayed in this, this is the results in terms of the districts, how they fared in terms of the assessment. And these are all the names for the districts, as you can see. And this is the current land degradation status in Botswana for this period. And we are further on. We have engaged a consultant to actually dig deep into the drivers of these land degradation aspects. And here is a map also showing this is the web-based platform which was created to share the data and information generated from the project. And this can be accessed through this link so that you can see what is in there. We've got the hectareage in terms of degradation per district and land productivity. And as you can see, I don't know whether you can clearly see it. We've got some platforms where you can click and dig the information that you can use for further analysis. So basically, when you're going to going forward, as Botswana, we are planning for this year to actually develop the Botswana National Restoration Strategy and to identify land restoration transformative projects and to prepare land degradation neutrality target setting. So this one, target setting, we have already started. We are having the second draft report, which we anticipate to complete it before the end of June, because the consultant contract is actually to expire before the end of June. And regarding the land degradation neutrality target setting. Let me take this opportunity actually to thank UNCCD Global Mechanism for actually contributing 40,000 US dollars for this exercise. We really appreciate it very much, and we promise that before the end of June, this will be done. What is left now to complete the exercise is to actually call upon the task team, what you call the UNCCD task force team, to actually validate the report which was produced by the consultant. And we also engaged the consultant to actually compile a detailed Botswana land degradation status report for 2022. And like you have mentioned, we actually delighted with and looking forward for the implementation of Botswana Sustainable Miombo Mopani Landscape Management Project. And we are also part of the SADC region, and we are so much delighted to tap into the Great Green Wall project. And finally, it's just to acknowledge the FAO office for actually carrying out the training, technical support, backstopping, and also the other departments, academia, for actually taking part in this whole process. And we also looking for sustainable forest management impact problem, dryland, sustainable landscapes. Delighted for the JEF7 project, which will be starting very soon. Thank you so much.
Thank you very much, Lesika. And now our final presenter will be very brief because it's very late. I'm delighted to present Nicole Harari. Probably most of you know her. She's, it's executive team member of course, WOCAT. She will present and will launch the community of practice on LDN within the Dryland Sustainable Landscapes Impact Program. So the floor is yours, Nicole.
You can just click, no, Ingrid?
Yes.
Okay. You can click on the next one. So as a last word, we have heard a lot of country experiences. Parties have requested capacity building yesterday morning. During around 1 hour there was the session, and a lot of parties have urged the convention to provide capacity building on the topic of land degradation neutrality. So what can we do as FAO and WOCAT to support this request for capacity building and link all these experiences together and foster South-South collaboration? So under the Drylands program, we are establishing a community of practice. The community of practice supports the sharing of tools and methods of learnings between countries, so we can facilitate an exchange, but we can also learn from state-of-the-art knowledge and link experts and practitioners and decision makers in order to use what we have and create and co-design, as Ingrid was mentioning, joint solutions and not start creating new solutions or new tools from scratch, but learning from countries, learning from experiences, and with that support the capacity development efforts under the UNCCD. And with that, here is a link to the global system that will be developed for these 11 countries. Again, it's a decision support system with the idea that the 11 countries of the Drylands program can work together and have one transparent, open access joint system available. Thank you, Ingrid.
There it is. Thank you, Nicole. And now for our closing remarks, it's my pleasure to present Vera Berger, Senior Land and Water Officer of FAO. So Vera, the floor is yours. Thanks.
Thank you very much, Ingrid. Thank you very much also for organizing this very interesting event. I think it showed us that there is a lot going on in the countries and that countries can learn from each other. It shows us also that the request which was mentioned by Nicole, that we need to validate the data and that we need national data in order to be able to do a proper planning, to take the right decisions. It is possible that we've got the right tools and the right support for doing that. I would like also to congratulate Turkey because, as I said already the other day, I think they have been leading the way. I think that there were different examples from Kazakhstan, Turkey, Bangladesh, Botswana and Ecuador. They have different purposes, different objectives, but I think the basic is the same. It's that you need information and data in order to take the right decisions and to make the right policies and to achieve land degradation neutrality. So in that sense, I think I congratulate. I think again, South-South collaboration is very important. We need to systematize. We do already. We have these tools to have this community of practice. I think it will help other countries as well to achieve their LDN targets and to plan in the proper way and also to achieve them and to monitor what they're doing. So with that, I would like to thank everybody for sharing the experiences and also Nicole, I think, for a wonderful partnership. I think we've been working on this for quite some time and I think it's showing results. And yeah, congratulations to everybody and have a good evening. Thanks a lot.
Yeah, there it is. Thank you, everyone. It's very late, and I don't know if there are any questions, but thank you for staying and for the speakers and the organizers of the Rio Pavilion and the Land Restoration Day. It's over. And on the request of Bangladesh, we would like to have a group picture, yes, from the presenters. Yes? Okay. So if there are no questions, we conclude this event. And we had food and drinks, but they never arrived, so... No, the catering is working. There is food, yeah? It's okay, then... Okay, so you can have a snack before you go. Thank you very much.
Thank you very much. Thanks for all of you who were here right from the beginning, right to the end of Land Restoration Day. Excellent. Such a great collection of presentations on tools and approaches, experiences at country level. Thank you very much. Congratulations. And I'd like to see the fact that this has all been linked up with all the discussions that are going on. So I hope that when we do the next iteration of this at our COP and again at COP27, we can look at integrating all these themes together. Thank you to everybody who's been here all day. Thank you.